Hello, thank you for joining today's session. My name is Yasin Baskan. I lead the product management team for Oracle's Autonomous Database. I've been with Oracle for almost 13 years now. I've been in the industry for more than 20 years, working as a DBA, developer, sales consultant, and product manager. The last couple of years, I've been looking after Autonomous Database since its inception. Having said that, let's move on to today's session. In today's session, I'm going to be covering and giving you a brief overview of Oracle's Autonomous Database and showing you a couple of capabilities it provides to make it easier for you to run, operate, and manage an Oracle database. A lot of the things I'm going to be talking about today are already available in the Autonomous Database, and you can use them. I will be mentioning a couple of things that are on the roadmap that we are working on. Those things are going to be available in the near future, again, in Oracle Autonomous Database. So to start with, to tell you about what Autonomous Database is before we go on to the capabilities and functionality it provides. Oracle Autonomous Database is a fully managed cloud service that completely eliminates the complexity of running and managing an Oracle database. It provides complete infrastructure automation, database automation, as well as it automates data center operations. You still get an Oracle database when you use an Autonomous Database. You still get all the rich functionality that the Oracle database provides, but without the complexity of running it. You not only get a database when you use Autonomous Database, you also get built-in tools, which are web-based applications that make it easier for you to do data management on your database. A couple examples include Oracle Machine Learning Notebooks to run machine learning models, Graph Studio for doing graph processing, data loading user interfaces, data analysis, data lineage analysis, impact analysis, as well as data transforms user interface for transforming your data inside your database or pulling data from other resources. So Autonomous Database gives you the complete package. It gives you the fully managed Oracle database as well as additional tools on top of the database. Autonomous Database, as I said, is a cloud service. It's available in Oracle's public cloud. If you want to run Autonomous Database in your own data center, it's also available in Exadata Cloud at customer deployments. Oracle Cloud Infrastructure, Oracle Cloud also provides dedicated regions for customers. If you want to run not only Autonomous Database, but multiple services from Oracle, you can have a region dedicated to yourself to run these services in. Autonomous Database is also playing nice and available in hybrid cloud configurations and multi-cloud configurations. We recently announced a couple of months ago Oracle Database Service for Azure, just to give you an example. This service is free of charge and allows you to provision and operate autonomous databases from your Azure tenancies. It links your Azure network to Oracle Cloud's network using the private interconnect. It provides low latency connections from your Azure clients to your Autonomous Database so that Azure customers, if you are an Azure customer, if you have Azure apps running on Azure Cloud, you can easily use Autonomous Database as your database for those applications. Autonomous Database supports all kinds of workloads. There are two major workload types that you choose when you're creating a database. One is Autonomous Database Transaction Processing, which is configured for running transaction processing applications. It provides raw format for storage. It provides large cache memory for storing data, for caching data. And it is configured for running transaction processing applications. The other one is Autonomous Data Warehouse, ADW. This gives you a pre-configured database to run data warehouses and data lakes. It's configured to run large table scans, large joins, aggregations. It has large memory for these types of operations. It compresses the data by default, so you save on storage costs. The underlying infrastructure and the database is the same for all these workload types, but when creating a database, you just mention what type of workload you want to run on it, and under the covers, the database is configured for that purpose specifically. So in addition to these main workload types, Autonomous Database also provides two other flavors or deployment types or workload types, you may call it. One is Apex application development. This gives you a database that you can use to code Apex applications, low-code Apex applications, and build applications faster than other development frameworks. The last flavor of autonomous database is autonomous JSON database. This gives you a database to run your JSON applications. It also provides, we recently announced this, it also provides a MongoDB compatible API. So if you have an application running on Mongo, you can move that data to autonomous JSON database and still use the MongoDB APIs to insert or retrieve data from the database. These two flavors of autonomous database are much cheaper compared to ATP and ADW that I mentioned before. So they have a low price point, but at any point in time, you can upgrade these to the full autonomous database with the click of a button. These two basically provide a subset of the functionalities that ATP and ADW provide. If we talk about the scale of the autonomous database today, just to give you an idea about how customers are using it, just to give you some numbers. Autonomous database today executes more than 10 billion SQL statements every hour. I mentioned the workload types and flavors of autonomous database. So these 10 billion SQL statements, queries, inserts, updates include transactional workloads as well as large table scans and data warehousing and data lakehousing type of queries and SQL statements submitted to the database. 22,000 databases are provisioned every month in the autonomous database service, and typical average provisioning time is 2-3 minutes. So it's really easy to get started. It's really easy to create a database and get started with the autonomous database. With that, let me show you a couple of capabilities that autonomous database provides to make it easier to manage databases. As I said, autonomous database is a fully managed cloud service. It automates things like creating databases, patching and upgrades, backup and recovery, disaster recovery. All the daily tasks that DBAs do on their Oracle databases are completely automated. Most of them are enabled by default, and some of them are able to enable some of them with the click of a button if you choose to enable them. Autonomous database is a wide topic, and it provides hundreds of features and functionality. For today's discussion, for the time's sake, I picked a couple of areas that I want to show you about in today's session. The first one is scalability. So if you look at scalability of the autonomous database, if you look at how people provision resources for their databases today and how they budget for these databases, we can talk about a couple of common methods used in the industry. The first one is static configuration, which is obviously pretty common in on-prem environments. You basically size a database server based on your peak workload. Even if your average workload requires 4 CPUs, if your peak workload requires 8 CPUs, you need to have a database server that can run 8 CPUs worth of workloads. Obviously, in this case, you pay for that resource, you pay for that server, as well as any kind of product licenses that are running on that server. Another one used in the industry by some cloud vendors is to scale in fixed sizes. So you provision a database resource, a server with some number of CPUs on it, and the system is able to look at it, and if the workload requires more CPUs, it can add 2 times, 3 times more CPUs or more nodes to it. The problem with this is it's in fixed sizes, so there is going to be some over-provisioning and some lag in identifying this resource need and adding these additional nodes to the database. The third one is completely open-ended scaling. The system scales based on data access patterns, data sizes accessed. Obviously, this is harder to control because it's open-ended and completely dependent on data sizes and access patterns. Autonomous database provides a much more dynamic and flexible scaling for scaling your database resources. First of all, it provides instant online scaling. You can add or remove compute resources immediately without bringing any application down. It doesn't provide fixed shapes. You can scale up by 1 CPU, 2 CPU, any number of CPUs you want, as well as you can scale down by increments of 1 CPU when needed. If you enable it, Autonomous Database also provides auto-scaling. By looking at the workload, it can scale up and down the compute resources up to 3x the amount of resources you provisioned initially. It also provides storage auto-scaling. If you keep inserting more data to your database, it's going to scale itself, and you won't need to do any manual operations for adding storage to your system. Auto-scaling allows Autonomous Database to charge and bill for exactly the number of CPUs you used as well. I'm going to show you an example in the coming slide for that. So if you look at how auto-scaling works in Autonomous Database, when enabled, it can automatically scale CPU and I/O resources up to 3x the amount of resources you provisioned initially. There is no downtime required. As the graph shows in the screen, if you provision the database with, let's say, 4 CPUs, but during the day, the workload you submitted needed to use 8 CPUs, it will scale automatically to 8 CPUs, and then it's going to go down to 4 CPUs again. And you're going to pay for these 8 CPUs that are shown here only for the duration of the time you used those 8 CPUs. This immediately provides, obviously, up to 3x better throughput for CPU and I/O intensive workloads. To give you an example of this, if you look at the graphs on the screen here, this testing shows the same workload running on 4 CPU Autonomous Database. The one on the left is auto-scaling disabled. The one on the right is auto-scaling enabled. We're running 24 queries, exactly the same queries, the same workload on both of these databases. So 24 queries on left and right. What you see on the left without auto-scaling is the database is configured to use 4 CPUs, which means 8 threads. It can run 8 sessions on the CPU concurrently. If your workload requires more, you will need to wait and compete for these CPU resources. Like in this example, 8 sessions are on CPU, 16 sessions are waiting on CPU. The difference is on the right, auto-scaling was enabled. So we allowed the database to scale itself up when needed to be able to run these CPU-intensive queries. So if you see here, 24 sessions are on CPU. There is no waits. Everything is green versus some of the sessions were waiting in the gray wait class here. So the database on the right is able to run 3 times more queries at the same time without any CPU waits at all. So what this means is the database with auto-scaling will be able to complete the same workload in 1/3 of the time, or it's going to be able to provide 3 times more throughput if you keep submitting queries and statements to the database with auto-scaling. The second capability I want to mention is reliability. Autonomous Database, as I said, is a fully managed cloud service. We automated everything with respect to reliability, and I want to show you a couple of numbers and examples when it comes to reliability of the database. So Autonomous Database uses highly available clustered Exadata infrastructure. Independent of how many CPUs you provision, all the databases you provision in Autonomous Database are placed in highly available Exadata infrastructures. Everything is redundant. Compute and storage and network failures are taken care of for you. You don't have to plan for or think about how to achieve availability with the Oracle database. It's done out of the box for you. For disaster recovery purposes, in case of a data center goes down or in case of a big disaster that impacts the whole region in any cloud, in Oracle's cloud, we also provide disaster recovery solutions that you can enable with the click of a button. That is going to replicate your primary database to a secondary location, and you can use that secondary database, the standby database, if a disaster happens. So if you look at how that happens, the feature we're using for this is Autonomous Data Guard. This provides a simple and transparent data protection for your production database. It takes 1 click to enable Autonomous Data Guard. You just say, I need a standby database for disaster recovery. You pick your region. It can be the same region as your production database. It can be a remote region. That's it. The rest is automated. The standby database is provisioned for you. We keep replicating your production database to the standby database. In case of a disaster, you can manually activate the standby database by saying, I want to failover my primary database to the standby database. On top of that, for Local failovers, if you have a standby database configured in the same region as the production database, the system can also automatically fail over in case of a disaster to your standby database and activate it. How it does this is it looks at if all your data was replicated from production to your standby database, and if it sees that it can guarantee zero data loss, it initiates the auto failover so that without even knowing it, your application can connect to the new primary database and continue running with zero data loss. If the system understands that there may be some data loss, it's on you. You as a user can decide whether you want to activate the standby or whether you want the failure in the primary region or the problem in the primary region to be fixed. So we provide recovery time objective and recovery point objective, obviously for disaster recovery purposes. The numbers we provide and guarantee in autonomous database for these are for local standbys. You have an RPO of 1 minute, so up to 1 minute of data loss you can have. And RTO is 2 minutes, which means in 2 minutes time, you can activate your standby database. For cross-region, for remote standbys, the RPO we provide is 1 minute and recovery time objective is 15 minutes. So we're continuously improving these. Being a cloud service, being a fully managed cloud service allows us to do things that we cannot do on-prem because we control and manage the infrastructure for autonomous database. We are working on a recovery point objective of 0, which means no data loss configuration. If you use DataGuard in on-prem environments before, this is the maximum availability mode as you know it, which means synchronous replication from primary to your standby database so that you don't lose any data if something happens to your primary or production database. Today, Autonomous DataGuard allows you to have 1 local plus 1 remote standby. We are working on improving this, and in the near future, we're going to be allowing you to be able to create multiple remote standbys in different regions if you choose to do so. So if you look at service level agreements, uptime SLAs, Autonomous Database provides guaranteed SLAs with credits if it's not able to meet these numbers. The SLAs, the uptime SLAs we have is 99.95 for all databases by default. So any database you create will have this SLA, uptime SLA. But if you enable Autonomous DataGuard, if you have a standby database running, the SLA is 99.995 in that case, because we are able to activate the standby and continue running your database. Autonomous Database also provides a manageability SLA of 99.95, which means all the API requests you submit to the Oracle Cloud for doing things on your Autonomous Database, like starting it, stopping it, all these API calls will succeed based on the manageability SLA that we provide, as I mentioned. So we really trust Autonomous Database availability, and the numbers show it. We are the only database cloud service in the market that provides availability numbers for each region. So if you search on the web for Autonomous Database regional availability, you'll be able to see a public page that shows you the availability numbers for the last 3 months for each Oracle Cloud Infrastructure region. In addition to that, we also provide you the availability numbers for the last months for your specific database. So if you go to your Cloud Console for your specific database, you're going to see a table that says the last 3 months availability for your database was this. So both regional availability and per database availability, we completely expose and publish these numbers for you. I mentioned being a fully managed cloud service allows us to do more things, more innovations in the cloud compared to on-prem databases. With respect to reliability, one thing Autonomous Databases provides is automatic detection of issues. So it continues to monitor all the database logs, all the infrastructure logs, and if it sees issues for your database, it automatically files bugs and SRs for the development team to fix these, and we fix these quickly and then patch your databases so that you don't hit these problems. So if you look at all the SRs filed for the Autonomous Database service overall, more than 87% of these files are automatically filed by the system. So without or before the customer even noticing a problem, Autonomous Database is able to identify these problems, file issues and SRs for these so that developers can fix and patch those problems before customers hit those. Patching and upgrades is another area where we completely automated the management of the database. You don't need to do any patching and upgrades in Autonomous Database. The way it works is, before I talk to you about how it works, let me show you a number. This number is coming from one of our customers who is managing around 10,000 databases. What they're saying is 75% of their DBA time is spent on patch management. When they see an issue, they file SRs, they get a one-off patch from Oracle, they have to patch all their databases, or they have to go to quarterly release updates and they need to manage and apply these patches. So they're saying a lot of the time of their DBAs are spent on patch management. So we completely eliminate this complexity in Autonomous Database. In the last 12 months, across the whole fleet, across all the regions in Oracle's public cloud, more than 4 million patches were applied in Autonomous Database without any database downtime at all and without any user involvement. These were completely automated patches that we applied. So patching is completely automated. As I said, in Autonomous Database, there's no database downtime. Database always keeps running. We use clustered infrastructure to apply rolling patches. These patches introduces bug fixes, security fixes, and also, as well as new features. We announced the maintenance schedule on the OCI console. You can see the upcoming maintenance window and patching window for your database. You can see maintenance history. You can see what was involved in these patches, what bugs were fixed in these patches. We also provide events and notifications for you so that you get notified when a patch is about to happen, 24 hours before, 1 hour before. We also notify you after the patch was applied, saying the patch was applied at this exact time frame. So today we announced these weekly maintenance windows, and you can see and plan for those if you need to. But in the near future, we're going to be providing flexible maintenance windows. So you can either choose your maintenance window, or if you have an end of quarter type of processing, or if you're in retail, some busy part of the year, you'll be able to say, I want to stop patching for this database for a specific amount of time and then continue patching after that. Backup and recovery is the next area I want to cover, which is, again, completely automated in Autonomous Database. We back up the databases continuously. You don't have to do any backups at all, and you don't have to worry about backups at all. The RPO, recovery point objective, or data loss tolerance we provide with these backups is 1 minute. So if you don't have a standby database, you rely on backups to restore your database if something happens. The maximum amount of data loss you will see is up to 1 minute. You can restore backups by click of a button in place, which means overriding your existing database, or you can also create or clone these backups as a new database. You can say, create a new database from this backup. You can also do point-in-time restore or clones for up to 60 days ago. We provide 60-day retention for all the backups, so you can go to any point in time in the last 60 days. You can use flashback features. You can flash back a table. If you drop the table, you can recover it back, or you can, if you want to see the data in the table as of some point in time in the past, you can say, select star from this table as of this date, and you're going to be able to see the old version of the data in that table. We are going to be in the near future providing flashback time travel, which means take this table back to 2 days ago or back to 3 days ago. You'll be able to set a retention period for time travel, and you're going to be able to travel back in time for specific tables or multiple tables if you choose to. So all this is completely free of charge in Autonomous Database. You don't pay any additional charges for these backups and restore operations. A lot of the customers have been asking for long-term backup retention because of regulations. So in the near future, we're going to be providing more than 60 days of retention if you choose to have that. So you're going to be able to specify backup retention of up to 5-7 years if you choose to. If you are in a regulated industry and you need to keep your backups for more than 60 days. A couple of capabilities Autonomous Database helps with the CI/CD pipelines or dev test lifecycles. Autonomous Database makes it really easy to create copies of production databases. You can easily clone databases. We provide full and metadata clones, so you can have a full copy of the production database, or you can create a copy of the production database that has the schemas without any data in them, so that different users can insert or load their own data into the same schemas. We provide read-only copies of production databases. These are called refreshable clones. You can create these. These will be replicated from production database. At any point in time, you can refresh these with actual data from production. I mentioned standbys before for disaster recovery. Another use case for these standbys is to be able to use them for read-write workloads for temporary amount of time. So in the near future, we're going to be providing snapshot standby functionality. I'll briefly talk about it in the coming slides. So refreshable clones, I mentioned read-only copies of the production database. You can use this to create test and dev copies, or you can use these to create reader farms if you have read-only workloads. Instead of connecting to the production database, these read-only workloads can connect to the clones and not impact the production database. These are read-only copies, but you can also disconnect them from the production database. This makes them a read-write database. You can run some testing, read-write testing on top of them. When the testing is completed, you can say reconnect back to the production database, and they'll convert back to a read-only database, and they will refresh with new data from the production database when needed. I mentioned the snapshot standby just to give you a little bit more explanation on that. By default, if you have a standby database, it's continuously replicated from the primary database with the RPO numbers that I mentioned before. But if you want to do some temporary tests on a production database and you need an immediate or quick copy of the production database, what you're going to be able to do is convert this standby to a snapshot standby. It's going to make it a read-write standby. In that case, you're going to be able to connect your applications and do your testing on this. After your testing is completed, you can say convert to standby again, and the replication will continue from where it left off, and then you'll have a standby database up and running quickly after this operation. So Autonomous Database is available on Oracle's public cloud. It also plays nice with all other clouds and all other services out there. So I want to mention a couple of features that are allowing you to do that. So Autonomous Database allows you to access all data lakes. It doesn't need to be on Oracle's cloud. It can be on Azure, Google, AWS. If you have data or data lakes sitting in any of these clouds, Autonomous Database can allow you to run queries on those files and data or load them into your Autonomous Database. You can control access to these clouds using their vendor-specific policies. So you can go to Azure and say, I'm allowing this specific Autonomous Database to access files in this specific bucket. And you can control policies and access using specific vendor provided policies for access. Autonomous Database also provides fully managed gateways. So if you have data residing in other relational databases like MySQL, PostgreSQL, MongoDB, Snowflake, Redshift, Azure SQL Server, and many others, you don't need to install anything to access these databases. By calling a simple API, as shown in this example, you can create a link to any of these databases, and you can use this link to pull in data from these sources, or you can even push data from Autonomous Database to any of these relational databases. So all these features allow you to easily build a lakehouse with Autonomous Database. I mentioned there is a workload type or flavor of Autonomous Database that is designed for data warehouses and data lakehouses. So by using the Autonomous Database, you can reach out to any database, any application running in any cloud out there, or any data lake, S3, Azure. If you have data sitting in any of these object stores, Autonomous Database is able to access those and manage those and process those for you. Autonomous Database is certified with all the common BI tools and applications out there, so you don't need to change your tool or migrate to a new tool. You can just continue using your existing applications and tools and connect them to the Autonomous Database. That's not the extent of it, though. If you do this, any data sitting in any data lake can be processed by Autonomous Database, but it also allows you, with the built-in functionality inside the database, to do spatial analytics, machine learning, graph analytics, text analytics on these data, either by loading them into the database or on the fly by accessing them without loading them into the database. As I said, it also provides built-in tools for data loading, data analysis, data transformations. So if you choose to use any of these built-in web-based applications, you can use them without the need to use any other third-party tool with your autonomous database. Last thing I want to mention with respect to capabilities is data sharing. Data sharing is popular and common in the market today. Autonomous database, as I said before, is able to access any database out there in any object store. So if producers put data in any of these object stores, autonomous database is able to consume them. We are able to also export to any of these object stores in multiple file formats. So you can do this today by manually exporting data into your object store of choice, and other people can read these. But in the near future, autonomous database will be supporting the open cross-platform data sharing, both as a data recipient and data producer. So autonomous database customers will be able to share data with other customers, whether they're autonomous database users or not. And autonomous database will be able to consume any data shared by API compliant data share producers. So I want to wrap up this session by showing you our customer references and stories. If you go to the URL here, you'll be able to see a lot of customers who are talking about how they use autonomous database and the benefits they get out of it. So this screenshot shows only a couple of them. There are hundreds of them. And you can go to this URL and read about their use case and learn about their experience with autonomous database. So before we close, the last thing I want to say is I randomly picked a couple of features that we released in the last couple of months just to show you the pace of innovation in autonomous database. As I said before, we control the infrastructure, we fully manage this service. This allows us to do a more fast-paced feature delivery and innovation. So every week we release 1 or 2 features. Every month we're releasing a couple of features to address customer requirements and solve customer problems. So compared to on-prem systems or on-prem databases, you'll see a lot more features released in autonomous database throughout the weeks and months to come. So thank you for joining today's session. If you want to learn more about Oracle Autonomous Database, you can go to the URL here, oracle.com/autonomous-database. You'll be able to see all the features and functionality. You'll be able to hear from customers as well. If you have any questions about Autonomous Database, you can reach to me using the email address provided on the screen, or I'm also on Twitter using the handle you see here as Yasin Baskan. So thank you again for joining the call, and I hope to talk to you again soon.